right, good morning, everyone. We're going to be on page 17 in our notes. We're going to continue solving trig equations and inequalities. So we're going to continue where we kind of left off yesterday. There's a few kind of twists today. So here we go. We're going to jump right in. The warm-up is here just to get us thinking about how we handle radicals and how we simplify a few of these and combine some of these. So if I was going to start solving, I'd subtract my square root of 5 from both sides. I'm going to be left with 5x equals 5 square roots of 5, take away a square root of 5 is not 5. 5 square roots of 5, take away 1 square root of 5 leaves me with 4 square roots of 5. Divide both sides by 5. I get x is equal to 4 square roots of 5 over 5. And that's as far as that one can go. All right, so let's jump into our trig equations. Notice that we're only on the domain from 0 to 2 pi, so all of our answers need to fall within that 0 to 2 pi of a circle or on a graph. So I'm going to start solving just like we did in the yesterday. We're going to subtract square root of 3 from both sides. We're left with 2 times the sine of 3x equals negative square root of 3. We're going to divide both sides by 2. So we have the sine of 3x equals negative square root of 3 all over 2. Now, just like we did yesterday, since I'm taking the sine of something other than just theta or x, I'm going to do a substitution. I'm going to let theta equal my 3x. So I'm looking at the sine of theta equaling negative square root of 3 over 2. When I do that solving, when I take my inverse sine is defined in quadrants 1 and 4. And when I take my inverse sine, I'm going to end up down here in quadrant 4 because I have a negative sine value. And my angle is this angle here. And that angle turns out to be pi over 3. And because it's going clockwise, it's negative pi over 3. However, my angle values need to fall between 0 and 2 pi. Negative pi over 3 is not between 0 and 2 pi. I need the positive version of this to end up in the correct domain. So the positive version of this starts at 0 and works its way around this way. So in order to find that, I need to take 2 pi and I need to subtract that pi over 3. And that leaves me with 5 pi over 3. So my answer that's in quadrant 4 is theta equals 5 pi over 3. Now, sine is also negative in quadrant 3. I need to figure out what that angle is. Now, my reference angle that I'm working with is pi over 3. So my reference angle is pi over 3. So in order to find this in quadrant 3, I'm going to take pi, and add pi over 3 to it. So theta is at 4 pi over 3. Now, that's what theta was equal to. We said theta now is equal to 3x, so we're going to replace that theta now. So we now have 3x equals 4 pi over 3. I need to solve for x. So I need to divide by 3 or multiply by 1/3 if you prefer. If I multiply both sides by 1/3, I'm left with x equals 4 pi over 9. That's my solution the first time around I get 4 pi over 9. Now, if this was asking for a general solution, x would equal my answer plus the multiples of my period. So if I go back to our equation, my b value is 3. In order to find the period, I need to take 2 pi, because that's the typical one for cosine, and divide it by my b value, which is 3. So the period of this graph is 2 pi over 3. So my general solution is going to be that 4 pi over 9 answer we got, plus 2 pi over 3 times n. Now, my first solution is 4 pi over 9. We need to use this counter when n is an integer. All right. What's our answer when n is 1? Well, when n is 1, x is going to equal 4 pi over 9 plus 2 pi over 3 times 1, which is just 2 pi over 3. Excuse me. I need to add our fractions together. Adding fractions, we need common denominators. So if I'm adding fractions, this 2 pi over 3, I need to change into ninths. 3 times 3 is 9, so 2 pi times 3 is 6 pi over 9. So my 2 pi over 3 is really 6 pi over 9. 4 pi over 9 plus 6 pi over 9 gives me an answer of 10 pi over 9. Is 10 pi over 9 still within 0 to 2 pi? Sure it is. 2 pi is the same as 18 ninths. So we're still in our solution range. So this is part of my answer yet. All right, let's do it again. When n is 2, I'm going to take this solution that I had before, and I'm going to go around again. I'm going to add my second period. The second set around, I'm adding my 6 pi over 9 again. I get 16 pi over 9. Again, ask yourself, is 16 pi over 9, within 0 to 2 pi? Yep, because it's still less than 18 ninths. Okay, but if we did it a third time, I end up with 22 pi over 9. That's greater than 2 pi. So that gets crossed off. I don't need that. That's not part of my solution. So far I have 3 answers. I have 4 pi over 9, 10 pi over 9, and 16 pi over 9. All of that, those are all angles that we used based off of our quadrant 3 solution. All right, let's go back here. We still have more to go. From our quadrant 4 solution, we had theta was equal to 5 pi over 3. Well, again, theta was the same as 3x equals our 5 pi over 3. So again, I'm going to divide by 3 or multiply by 1/3. We get x equals 5 pi over 9 this time. That's one of my solutions. Then, if I'm thinking about that general solution again, x is going to equal that 5 pi over 9 plus the multiples of the period. Well, my period is still 2 pi over 3 times n for the multiples, where n is an integer. All right, so again, we're going to do the same thing. If I go around one more time, if n is 1, If I plug in 1, I'm taking 5 pi over 9 plus 2 pi over 3. So 5 pi over 9 plus 2 pi over 3. Oh yeah, common denominators. So I'm going to add 6 pi over 9. I get a solution of 11 pi over 9, which is still within 0 to 2 pi. All right, I do it again. N is 2. I'm going to take my 11 pi over 9, and I'm going to go around again. Excuse me. So I have to add my 2 pi over 3, which is 6 pi over 9, and that gives me a solution of 17 pi over 9. Now, if I added another one, I'd be past my 2 pi. So that's as far as I go. My solution list, if I put them in order, we had 4 pi over 9, we had 5 pi over 9. That was from our first cycle of our graph. Next cycle gave us our 10 pi over 9 and our 11 pi over 9. And our last cycle around gave us 16 pi over 9 and 17 pi over 9. All of these are the solutions for x way back at the beginning. So if we think about what we had a horizontal dilation, technically with a factor of a third. So that means this 3 here means I'm going to get 3 waves within my typical 0 to 2 pi. Typically, we get 2 answers from every 0 to 2 pi. Well, now I have 3 times as many. 3 times 2 gives me my 6 solutions. All right, let's try another one. Let's flip the page. Number 2. Looking at number 2, I'm going to start solving just like I did the other one. I have 2 times the cosine of 2x plus 3 root 2 is less than. So this time we have an inequality to deal with on the domain of 0 to 2 pi. Excuse me. All right, so inequalities, we're going to start by solving it as an equation. I'm going to subtract 3 root 3 from both sides. If I subtract 3 root 3, 2 root 3's minus 3 root 3's is negative 1 root 3's. Divide both sides by 2. I'm looking at the cosine of 2x equals negative root 3 over 2. That's one of our special angles. So when I think about what that is, again, I'm going to make that substitution. I'm going to let theta equal my 2x. So I'm solving the cosine of theta equaling negative root 3 over 2. Inverse cosine is defined in quadrants 1 and 2. Giving us a negative value is going to give us the solution in quadrant 2. The inverse cosine of pi over 3, the inverse cosine of root 3 over 2 is pi over 6 as a reference angle. Because we're in quadrant 2, I'm going to say theta, oops, let me do that in blue. My quadrant 2 answer, theta is going to be pi minus that pi over 6. So theta is equal to 5 pi over 6. Now, Cosine is also negative in quadrant 3. So I need my quadrant 3 solution. And in that case, theta is going to be equal to pi plus that pi over 6. So theta equals 7 pi over 6. Now, as a reminder, we didn't have a theta in our problem. We had a 2x in our problem. So instead of theta, we're going to replace that back. 2x equals 5 pi over 6. And 2x is going to equal 7 pi over 6. Let's divide by 2, which is the same as multiplying by a half. So we get solutions of 5 pi over 12 and 7 pi over 12. Those are our two solutions from the first time through. So this is where we have to think about our general solutions and what our period would be. General solution would be 5 pi over 12 plus multiples of the period. So I'm going to go back here. My b value is 2. So to find the period, I need to take 2 pi, the typical period, divided by b, which is 2. That gives me pi. So my general solution would be x equals 5 pi over 12 plus pi n. So my first solution is 5/12. Then, if I do it again, if I say n is 1, my solution is 5 pi over 12 plus pi times 1. So I'm looking at 5 pi over 12 plus 12 pi over 12. My second solution is at 17 pi over 12. Now, if I go let me highlight that. If I go another round, if I add another 12 pi over 12, I end up with 29 pi over 12, and 29 is past my 2 pi. So I don't want to do it again. So these two solutions from quadrant 2 solution, I got to do one more over here. So I have my quadrant 3 solution, my general case here, x equals 5 pi over 12, 7 pi over 12, plus my pi n still. So if I use my n as 1, 7 pi over 12 plus my pi, which is 12/12. So I get a solution of 19 pi over 12. Fantastic. I have my 4 solutions. I have my 4 places where they're actually going to equal each other. But because it's an inequality, I need to draw myself a sketch of my graph to see where the inequality part's going to happen. So if I do that, I know I want to go from 0 to 2 pi. I know my typical period is pi. So I'm going to put a little mark here at pi. And I'm going to put another mark here at 2 pi. Now, we have to see where this stuff is. All right, looking up here way at the beginning again. I have an amplitude of 2, and everything got shifted up 3√3. The 3√3 becomes my midline. So my midline, I don't know where it is, but it's at 3√3. My amplitude is going to go from my midline up 2 and down 2. So I'm looking at 3√3 plus 2 for my maximum, and wherever 3√3 minus 2 is for my minimum. So here's my midline. This is a cosine graph. So this entire cosine graph is going to start up at my maximum, go through everything, come back through the midline to my minimum, back to the midline, back to my maximum by the time it gets to pi, because pi is my period. And then it repeats again. It goes to the midline, goes down to the minimum, goes back to the midline, comes back to my maximum. So my graph looks like that. So the question is, now I need to know the inequality part. My inequality is asking where it's less than 2 root 3's. Well, if this is 3 root 3, 2 root 3's are down in here somewhere. We found these 4 locations where our 2 root 3 line hits our cosine. So if I put my values in order, this first one was 5 pi over 12. My second one was my 7 pi over 12. My next one over, on my next cycle, is 17 pi over 12. And my last one is at 19 pi over 12. So I want to know where my solution, my cosine is less than that. Where my cosine graph is lower than my 2 root 3 line. Well, that's happening here and here. So my solution is going to be, now it's not an or equal to, so it's not inclusive, from 5 pi over 12 to 7 pi over 12, that interval, along with the interval of 17 pi over 12 to 19 pi over 12. If I was there, I'd say, are there any questions? I'm not there. I can't answer your questions. All right. We're going to get started on the next one. I don't know if we'll get through the whole thing, but here we go. Again, this one's an equation, and we're looking for solutions that are just from 0 to 2 pi. But we have a multiple angle in there. So here we go. Oh, and we have a cosine squared. Oh, got lots of stuff. So first things first, let's add our 3 to both sides. We're going to divide by 4. And it's a cosine squared. So I have to take the square root of both sides. If I take the square root of the left side, that square and square root will cancel, and we're going to be left with the cosine of 3x. On the right side, because I take the square root, I'm going to have a positive and a negative version of the square root of 3/4. Square root of 3/4 is the same as the square root of 3 over the square root of 4. Well, that gives me plus or minus the square root of 3 over 2. And that's a special angle. So, if I think about where this is going to happen, I want to know, let's do this first. I'm going to let theta equal my 3x. So I'm actually solving the cosine of theta equals plus or minus root 3 over 2. Because I'm looking for the positive and the negatives, I'm looking for things that are happening in all 4 quadrants. So my reference angle that gives me a value of root 3 over 2, the cosine, is pi over 6. So I'm going to have from quadrant 1, theta equaling pi over 6. But cosine is also positive in quadrant 4. It's negative in quadrant 2 and in quadrant 3. So I actually need all 4 quadrants. So quadrant 1 gives me a solution. Quadrant 2 is going to give me my first negative root 3 over 2 solution, and that one is theta equals 5 pi over 6. My quadrant 3 solution is going to be my second negative value, which is theta equals 7 pi over 6. And then my quadrant 4 solution, theta is going to equal 11 pi over 6. All right, but now we don't just have theta, we actually have 3x. So we're going to go back and replace. Oops. So 3x equals all of these. Whew. And now I have to multiply everything by a third or divide by 3. So we get pi over 18. We get 5 pi over 18. We get 7 pi over 18. And we get 11 pi over 18. Okay, so general solutions, excuse me, would be our pi over 18 plus, what's the period? My b value is 3, so 2 pi divided by 3 times n. I have my 5 pi over 18 plus my period. I have my 7 pi over 18 plus the period. And I have 11 pi over 18 plus the period. All right, so now we need to find all of our others. So just like we did with the other one, if n is 1, I'm going to take my pi over 18, and I need to add 2 pi over 3. But we're dealing with 18ths. So 2 pi over 3 in terms of 18ths, multiply by 6, multiply by 6, we get 12 pi over 18. So I get a solution of 13 pi over 18. And I need to do it again. If I go to 2, I'm going to take my 13 pi over 18, and I'm going to go around my period again. So I'm going to add my 12 pi over 18, and I get 25 pi over 18. Now, if I go around again, and I add another 12, I'm at 27. I'm sorry, 37. So I'm past my 2 pi value. So from my quadrant 1, I have 1, 2, 3 solutions. You now need to do the rest. When you're done, you should have 3 solutions from here, 3 solutions from quadrant 2, 3 from 3, and 3 from 4. So at the end, I believe you should have 12 answers. So I'm going to let you finish that, and that's as much as we need. Have a great day.